Hey, I'm Kevin Schwanger.
I'm Chris Jean-René.
And I'm Kyle Shreve. And for our ENME 441 final project, we made an arcade game inspired by the board game Battleship.
Alright, I'm going to walk you through the web interface used to place the ships and start the game. So first, the HTML page presents the playing grid, where each container holds an input checkbox. It asks the user to place their first ship, the battleship, and specifies the amount of coordinates and a little bit about how to play the game. So the user clicks each checkbox that they want and hit submit to submit their ship. The CGI code reads this and checks to make sure that the ship is valid, meaning each coordinate is next to each other and in the same row or column. If this is the case, it saves it to a JSON file and then asks the user to place the next ship, which is the submarine. If the user does not submit a valid ship, like this, then the CGI code will read the submissions and load the previous coordinates in order to separate the ships, and then does the same validation function to make sure that the ship is valid and in the same row or column. It then does this until all ships are submitted and the game is ready to start. Now that every ship has been submitted, the JSON file is updated for the background code to read and display on the LED board.
So now that all the ships have been placed, I'll show you what the other player will do. So first we start the code here, and that tune plays and the game begins. This grid of LEDs shows you all of your guesses, while this grid over here shows you your hits. So first I'm going to take a guess by pressing this button to fire. And as you can see on the screen, it says miss. And now I'm going to hit one. And it plays that sound to alert you that you've hit a ship. So now I'll sink the ship here. And it plays another sound and writes Battleship sunk. And it shows you what ship you sunk as well. So now I'll go through and sink all of the ships. That's another hit. And now the submarine has been sunk. Next, this is the cruiser. Cruiser sunk. And the last ship, which is the destroyer. And it says game over, all ships sunk, and plays another tune.
So now that we've seen the setup as well as the gameplay of our project, I can run you guys through the hardware. And one of the things we're really happy with about our project is how our custom 3D printed parts turned out. Namely, our LCD screen casing, as well as our custom Battleship controller, which houses our joysticks, the buzzer, and LED 8x8 grids. I can also show you under the hood so you guys can get an idea of the circuitry behind our project. Now, the brain of this whole operation is our Raspberry Pi, but a couple other things of note are the shift registers, which are underneath all these wires, as well as our analog to digital converter. And in terms of how those impact our project, we have these two LED 8x8 grids. So if we were to independently control the signals going to these LEDs, we would need 128 GPIO pins on the Raspberry Pi, which unfortunately we do not have. That's where the shift registers came in. Shift registers sequentially read in states from a certain pin and stores them until their latch pin is pinged, and then it simultaneously sends out all the independent signals to their respective wires. Basically what that means is instead of requiring 128 pins to run these LEDs, we only need 6, so that's a huge convenience. The analog to digital converter is used to convert the analog signals from the X and Y potentiometers on the joysticks to digital signals that the Raspberry Pi can read and manipulate to generate these patterns. Finally, the buzzer and our joystick buttons are just operated through the standard GPIO pins on the Raspberry Pi. And overall, we're very happy with how this project turned out. It's a ton of fun for even us to play. and thank you very much for watching.